Okay, hello everyone, and welcome to class 3. Okay, so a couple things before we get started. So make sure to first answer the review questions on Google Classroom. So I've posted some review questions there, and this is I feel like this is a really great way to test your knowledge on the topics that we've been learning. And I will give personalized feedback to each one of your responses to those questions. So make sure you check the Google Classroom for that, okay? Yeah, and in today's class, we'll be learning basic Python, NumPy, as well as Matplotlib, okay? And so we're going to be starting by finishing yesterday's class on the Linear Algebra crash course. Then we'll be going on to Python, which is a useful language to learn in general, especially within machine learning. It's a very, very powerful tool. And if you don't know what Python is, it's a coding language, okay? And then we're going to be learning about NumPy, the NumPy library within Python, which is useful for data manipulation and writing matrices and vectors in terms of code, okay? Yeah, then we'll be going on to Matplotlib. So Matplotlib is used to graph our results after we've done machine learning. And then as homework, you'll be discovering this tool called Google Colab, okay? This is a powerful machine learning collaboration tool based on the language Python. And so what you're going to do is I'm going to use some instructions. You're going to go over there, read the instructions, fill out some code, and I'm going to give you some hints. And then we're going to be using Colab in class 4 and 5, right, for the hands-on project. Okay, so lastly, note that this class is being recorded, and let's get started. Okay, so we left off last time on the identity matrix, okay, in 2 dimensions. So we had covered already. Let me make this full screen. So we had covered the dimensions of a matrix after matrix multiplication, right? So we studied matrix multiplication in terms of 2-dimensional matrices, and then we were about to go on to the identity matrix, but we did not have time to do that. So that's what we'll be starting with, okay? So the identity matrix is a matrix which is just it's a 2-dimensional matrix, which is like this, okay? So there's ones on the on one along the up left to down right diagonal, and then zeros everywhere else, okay? And so this right here is in 2x2 dimensions, okay? Its dimensions are 2x2, right? So it's denoted as I and base sort of like a subscript 2, okay? Capital letter I in bold, and then lowercase 2. And then so this is kind of like a random matrix made of zeros and ones. So you might be thinking what's so special about this? So that's what we'll be seeing in this this section. So we're going to be computing the vector AB, right? So the vector AB times the identity matrix. So we have to always have the matrix first, right? So we have the identity matrix, which is this guy over here, and we're multiplying it by this vector defined as AB, okay? And so in order to do that, remember, we have to take the dot product of this first row right here. We're going to take this guy and do the dot product of that and this, right? And you do the dot product of this and this, right? And then you just stick those two answers together into one vector. And if you do the arithmetic, what you find is that you get the AB to be your answer, okay? But this right here, this answer right here, is just the vector that we started with. This is just AB that we started with before. So the identity matrix is really special because if you multiply the identity matrix by anything, you'll actually end up with that same thing. So in this example, we had multiplied the identity matrix by some vector v, right? Then then we found that we actually ended up back at V, right? So we're going to look at another example where instead of starting with a vector, we start with a matrix, which is A, B, C, D. And it turns out if you do the arithmetic, I subscript to, right, this is the identity matrix, times A, you get A, B, C, D, which is what you started with. That's what you started with. So it's kind of like multiplying by 1 in terms of like the numbers that you and I deal with every single day. So if I multiply 5 by 1, I just get 5, right? If I multiply 10 by 1, I just get 10. And then if I multiply anything by 1, I just get that same number, right? So similarly, if you multiply the identity matrix by anything, you'll end up getting that same thing that you multiplied the identity matrix by. Okay, and it turns out that you can actually switch this order over here because matrix multiplication is defined either way. So A times the identity matrix is defined, as well as this guy right here, identity matrix times A. So either way you would put this, they would still hold, and they would still give you this answer over here. Okay, so that's the identity matrix. It gives you the same answer that you just started with. Okay, and so when we multiply the identity matrix by any vector or matrix, we get that same vector or matrix as our product. So this hints at the name identity matrix because it doesn't change the identity of anything, right? So that's all well and good, right? But there are also some uses for this, and so for one, the identity matrix helps us to define other concepts, which we'll now be looking at. But before that, I want to just make sure nobody has any questions. So does anybody have any questions on that? The identity matrix? Okay, cool. Yeah, all it's saying is like multiplying by 1, right? Kind of like that. So yeah, so now we're going to be looking at the inverse matrix in 2 dimensions. So the inverse matrix in 2 dimensions is defined or is denoted as a sort of to the power of -1. You're not really raising it to the power of -1 or anything, but that's how you would denote it. Okay, that's how you would write the inverse. Then you have basically how you define this is that a multiplied by its inverse, right? So a to the power of -1 is its inverse, right? So a times its inverse is going to be equal to the identity matrix, okay? And if we reverse the order of this right here, we actually get the inverse of a times a equals the identity matrix once again. So the a or the identity or a or the inverse of a times the other one will always equal to the identity matrix, okay? And so we have to note that A is a matrix in 2 dimensions, okay? So it has to be a 2 by 2 matrix, okay? And so from this, we can define singularity. So essentially, when a matrix is singular, it satisfies 2 conditions. First of all, its determinant is 0, and second of all, it doesn't have an inverse. Okay, and if it's non-singular, then it has an inverse, and its determinant is not 0. Okay, so we'll be looking at why this sort of makes sense, and there's also geometric interpretations. If anybody's interested in that, I can tell you about it later, but just for the sake of time right now, I'm going to go on. So we're going to try to find the identity matrix. Sorry, we're going to try to find the inverse matrix in this problem. So let's let A be the matrix A, B, C, D, right? Pretty basic. Then we want to know what is A, this matrix right here, multiplied by this term right here just means 1 over the determinant of A, B, C, D, times D negative B negative C A. Okay. So if you notice what we're doing here, we're switching the A and the D, the order of the A and the D, and we're taking the negative of these two. Okay, and we're multiplying it by this right here. And if you notice, A, B, C, D, the determinant of that, as we discussed last time, is actually just a number. So this is a scalar right here, a number, right? The numbers that you and I deal with every day. So it's 1 over some number multiplied by D negative B negative C A, right? And then so basically this whole thing right here multiplied by A has to be, or so we're trying to find out what that is, right? And if you do the computation, and I strongly urge that after the class you try this on your own, you will find that so this product right here will end up being the identity matrix. It'll be the identity matrix, okay? And then this right here, this product right here, where we just switch the order of A and this big term right here, where we switch that order, it just ends up being the identity matrix once again. So our answer is the same each way, okay? So it's the identity matrix once again. And now, so remember how remember how the inverse matrix is found. The inverse matrix is defined as when you multiply a matrix by its inverse, you get the identity matrix. And so that's what we did. We multiplied some matrix by another matrix, and we got the identity matrix. So that must mean that this guy right here is the inverse, okay? And to derive this, so we just proved that this right here is the inverse of A. But to derive this, it would take like probably more complex things than we're going to be learning in this class. But we proved it in this class that that this right here is the inverse of A, because when you multiply A by this guy over here, you get the identity matrix, and that's how we define the inverse of A. Okay, and then over here, it's the same matrix once again, right? So this is the inverse of A as well. So both of these right here equal the identity matrix, and that's why this right here is the inverse of A. Okay. So now we know a little bit about why if you remember it right here, it says that right here it says the determinant is 0. As well as it does not have an inverse. So basically that implies that if it doesn't have an inverse, then its determinant is 0, or vice versa, right? So let's think about it. If the determinant is 0, right, and this is the inverse matrix, remember the determinant is 0, so this guy down here, this is 0. But this is in the denominators, right? So 1 divided by 0, that would be undefined. So we have a little bit of intuition why this doesn't work, right? And so if it isn't 0, then this is just like a scalar, right? This is just scalar multiplication. Then we can find the inverse matrix, okay? And so yeah, so we're going to be looking at this a little bit later, but before that, does anybody have any questions on that? Problem 26. So this one right here. So all we did was like we were given this matrix as if it fell out of the sky, right? And then we were asked to multiply this by A and reverse the order and then do the same thing again, right? So it doesn't matter how we got this because that's not what we're not going to be focusing on that in this class. But we proved that this multiplied by this huge looking matrix over here ends up being the identity matrix. And if you remember, we defined that as a matrix times some other matrix right here equals the identity matrix. And so that's what we have over here. This matrix times some other matrix, right, equals the identity matrix that we proved, right? And because of that, this must be the inverse in order for this right here, this whole thing, to be equal to the identity matrix. Okay, does that make sense? Cool. Okay, anybody else have any questions? Okay, I guess I'll be moving on. Um, let me see. So now we're going to be using matrices to solve this right here. And this might look very intimidating at first, but if you just multiply it out, so you have to take the dot product of this guy and the dot product of this, or like the dot product of this matrix, or sorry, this vector right here, 5, negative 6, and xy, right? So when you take the dot product of those two, you multiply 5 by x, negative 6 by y, so you get 5x minus 6y, and then that's the first component of the resulting vector, right? So 5x minus 6y must be equal to the first component of this vector right here. So that must be equal to 3. So 5x minus 6y has to be equal to 3, right? And then you can essentially what I'm saying is that you can derive some like linear equations, and then you can solve them, right? But that's the boring old method, right? We're not going to do that. What you can do is you can multiply the both sides by the inverse. So when you multiply both sides by the inverse, you actually, if you multiply this side by the inverse, right? Then you get, when you multiply both sides, you multiply both sides by the inverse of this. Okay, that's what I was talking about. So, and then you multiply both sides by the inverse. Remember, you just get the identity matrix, right? So when you get the identity matrix on this side, right? And remember, you have to multiply the inverse on the other side as well. So the identity matrix multiplied by xy, that just becomes xy, right? And I'll show you this in more detail in the next slide, but then you multiply the inverse of this matrix on this side as well. And once you do that, you get xy and then another vector on the other side. But let's go into more detail as to how this works. So I know that was a bit like hand wavy. So let me talk to you about it more in detail. So over here, this right here, let's define this as A, okay? And then we'll define this guy right here as V, and then everything else is just the same. So we get A, right, which we replaced in our equation, multiplied by xy equals V, okay? And so hypothetically, if we solve for A, like the inverse of A, right, using the thing that we derived from the last problem, we can multiply both sides by the inverse to get, so we multiply this side by the inverse, and we multiply this side by the inverse as well. And over here, right here, the inverse of A multiplied by A, remember that by definition, this is equal to the identity matrix, right? And then multiplied by xy equals xy, right? Because the identity matrix times any vector will just equal that vector. So we can just simplify this to just being xy. We don't care about the identity because the identity matrix doesn't change anything, right? So then this is supposed to be equal to the inverse of A times vector V, okay? And I want to talk to you a little bit about why I put this guy on the left instead of on the right. So if you remember, matrix by vector multiplication is not commutative, meaning if you reverse the order, it's not the same. It might not even be defined for that those dimensions, right? So it's not. So we can't. If we're multiplying on the left side over here, we have to multiply on the left side over here. Otherwise, the dimensions won't stay intact. Okay. Then essentially we get this guy right here. And so we're saying that xy is equal to the inverse of a multiplied by vector v, right? And so if we replace the values of the inverse of a in the vector v, remember by the last problem, we can actually calculate what the inverse of a is, okay? And then we can multiply that by the original vector that was there. Just if you go in the last slide, this vector right here, that was what v was in the first place, right? So if we multiply this guy, the inverse, multiplied by v, as per this equation right here, it should be equal to x comma y. And we get negative 3 over 20 over negative 5 over 8. So this right here is the answer to x and the answer to y, okay? And that was a very, I think that would be like considered a pretty complicated problem. So does anybody have any questions on that? Any part they want me to review on that one? Okay. Okay, I just want to make sure you understand it. I don't want to go too fast. Okay, so does anybody else have any questions? Okay, let me know if you have a question. Okay, you can just shout it out, or you can tell me to check the chat. Okay, so yeah, these are some problems we won't be doing, but you should do them on your own because the handout is on Google Classroom. Make sure you do those. And so now we're going to be generalizing this. Okay, we did all of the dirty work. Now we're going to generalize it to more dimensions, and this is going to be very, very quick, very, very rapid. And that's because like we already did all the dirty work, so we don't need to go into the proofs and such like that. Okay, so first we're going to redefine what a vector is. So remember, we only had last time we had a vector which was two components, right? This time we're going to be defining vectors as just a list of numbers, a list of scalars, okay? So this could be like 1, 2, 3, 4, 5, or something like that, right? You could have as many numbers in your list as you wanted, right? And so this right here, if this has n elements, right? So A1, A2, A3, all the way to AN, you have n different elements over here. They don't have to be different, actually. Then you say that it's an n-dimensional vector, or a vector of length n, okay? And matrices are defined in the same way. It's just a string of different vectors, okay? So you just put vectors together, and then you just remove the parentheses and put parentheses around the whole thing, okay? So that's our new definition. And by this definition, we can have, in a matrix, we can have as many rows, as many rows or as many columns as we wanted, right? So this is just a grid of numbers, okay? Just numbers and numbers and numbers and numbers, right? And yeah, so the dimensions of a matrix are the number of rows in the matrix multiplied by the number of columns in that matrix, okay? A square matrix is a matrix which has dimensions n by n. So like the same number of rows as it does columns, okay? From this point onwards, we're going to be talking about like the properties of vectors and matrices in the same sort of manner, because you can consider a vector to be a matrix with only one column, right? So if you have a matrix that has only one column, then it only has a unlimited number of rows, but it's confined to one column. So that's what that's what a vector is, right? So they're essentially the same thing. And in Python, NumPy, you actually denote them as in the same manner. Okay. So we're going to be doing first matrix addition and subtraction. And you might be thinking this is like exactly the same thing. So in matrix addition, we would add so we can only do matrix addition or subtraction if the two matrices have the same dimensions, right? If I have a 2 by 3 matrix, right, then I can only add it to a 2 by 3 matrix, right? Then when you add these two matrices, then you have to add the corresponding elements, okay? That's all you do. You add the corresponding elements, okay? And then that's your answer. And then matrix subtraction is when you subtract, instead of adding the corresponding elements, you subtract the corresponding elements, okay? And I think that's also pretty basic. Even though we didn't cover it, I think that's pretty intuitive. And so now we're going to be moving on to scalar multiplication, okay? Scalar multiplication is when you multiply a matrix by a real number, the numbers that you and I deal with every day, right? So, so a matrix, like when you multiply a matrix by a number, all you do is you multiply every single element in that matrix by that number that you started with, right? By that scalar, okay? Now we're going to be moving on to the dot product, okay? So the dot product is when you have two different vectors over here, right? So if this vector v is a1, a2, a3, all the way to an, you can only multiply them if, or you can only have a dot product if they have the same dimensions and if they're vectors, right? So if they have the same length. So both of these have length n, right? So this is b1, b2, b3, all the way to bn. So both of these have length n. And if we multiply, or I mean the dot product, right? So of v and w, that's denoted like multiplication without the x. Instead of the x, you put a dot right in between. And so v dot w, right? Right, for dot product. You multiply the corresponding elements or the corresponding components. So a1 you multiply by b1, a2 you multiply by b2, a3 multiplied by b3, right? So you multiply the corresponding elements all the way to an multiplied by bn. And then you would add all of these products that you get. So you would multiply the corresponding elements and then add them, okay? I don't feel like that's really far-fetched to compared to like what we've been doing with the dot product, right? Now we're going to be using this to define matrix multiplication. So matrix multiplication is defined, or matrix multiplication by a vector first. Matrix multiplication by a vector, what you do is you take each row of the vector A, right? And you put it into a vector, okay? And then you multiply, or you take the dot product of that vector and the vector that you're multiplying A by. So you have, when you're multiplying A and vector V, you take the first row of A and you put that into a vector, and then you multiply that by V, or take the dot product of that and V, okay? And then that becomes the first element in your resulting vector, okay? Then you do that for the second row of A. Then you do that for the third row of A, and then the fourth, and the fifth, and the sixth, all the way for as many rows in A as there are, okay? And you can only do this, obviously, if the dot product is defined, right? And the dot product is only defined if the number of columns in A, right? The number of columns in A, that's the number of, that's the length of the vector that you're going to take, is you can take the dot product of that vector and vector V. In other words, the number of columns in A has to be equal to the length of vector V, okay? And so that's how you get like matrix multiplication by a vector. Now we're going to be going on to matrix multiplication by a matrix, okay? So if I wanted to multiply A by B, remember that the number of columns in A has to be equal to the number of rows in B, okay? Then let's let the vectors that make up B, so the column vectors, right, that make up B, to be B1, B2, B3, all the way to Bn. Okay, so what you would do is you would multiply A by B, then you would multiply A by A by B1, A by B2, A by B3, all the way to A by Bn. So as many columns in n as you have. So you have like basically the if you have a matrix B, you dissect it into its individual column vectors, right? And then you multiply the matrix A by each one of those column vectors individually. Then whatever vector you get as your result, you just string those vectors into a matrix, and that's your answer. Okay, it's not too different from what we've been doing. Okay, with in two dimensions, right? Yeah, and so remember that matrix multiplication is not commutative. Okay, first of all, it's not commutative. So writing it in terms of A and B is not the same as writing in terms of B and A. Okay, so then you also have that matrix multiplication is not is associative, meaning that A times B, right, times C is not equal to, is equal to A times B times C. Okay, so B times C, if you multiply that by A, that's equal to A times B times C, right? Okay, now with the identity matrix. The identity matrix is a square matrix, meaning it has n by n dimensions, right? Where this diagonal right here from the upper left to the bottom right is are all ones, and everything else is 0. Okay, and so just like in 2 dimensions, if you multiply the identity matrix by anything, then you'll get that same thing. Okay, so for vectors and matrices, if multiplication is defined, then you will just get the same thing. Okay, and we can so this is the inverse of a matrix. So the inverse of a matrix is defined as some matrix multiplied by its inverse and is equal to the identity matrix. Okay, and the inverse multiplied by A, right? So like any way you multiply these two, you'll always end up with the inverse. Okay. Sorry, I mean the identity matrix, and yeah, some identity matrix. Yeah, and yeah, I forgot to mention that A has to be a square matrix. Otherwise, you can't take the inverse of A. Okay. And so if like a matrix has an inverse, it's non-singular, and if it is singular, then it doesn't have an inverse. Okay, just like last time. So if it has an inverse, it's non-singular. If it doesn't have an inverse, it's singular. Okay. And now we're going to be introducing a new idea called the transpose of a matrix. So this isn't very complicated. The transpose of a matrix is just when you flip the rows and columns. So essentially, you take a matrix, and the first column becomes the first row, and the first row becomes the first column. Similarly, the second row becomes the second column, and you switch those two, right? And the third row becomes the third column. Fourth row becomes the fourth column, and so on and so forth, right? So if we have this matrix right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 25. Then you would switch right here. This first row would become the first column. Okay, so it becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? All the way to 25. So instead of counting like left to right, you're counting up to down. And it's similar to sort of if you know about reflections, if you draw a line right here, and then if you reflect the elements over that line, then 2 will be reflected onto 6, and 6 will be reflected onto 2. Then 3 will be reflected onto 11, 11 will be reflected onto 3, right? So 6 is over here, 2 is over here, right? So they exchange positions. 11 and 3 also exchange positions. 8, 12 exchange positions, and 4 and 16 do as well. So the transpose of a matrix has a lot of great properties, but we won't be covering that right now. And so yeah. Yeah, so basically this was the mathematics behind machine learning. And so this will allow you to understand what happens in machine learning as opposed to blindly applying algorithms like random algorithms, random libraries, right? And so now we will be moving on to uh, to an introduction to Python, NumPy, and Matplotlib. Okay, but before that, does anybody have any questions? We might go like significantly over time. Okay, so feel free to drop the call, but um, yeah, just watch the recording afterwards. So does anybody have any questions? Okay, thank you for letting me know. Okay, so as I said, we're going to be covering Python, NumPy, and Matplotlib. Okay. Yeah, and now we're going to be covering first the data types, defining variables, printing outputs, operations and integers, slicing through strings and lists, conditions, elif and else statements, for loops, while loops, right? And that's and then that's for the in terms of Python basics. Then we're going to be moving on to NumPy arrays, so defining vectors and matrices, and um, then operations with NumPy arrays, size and shape of an array, accessing elements of an array, special NumPy arrays, statistics of an array, right? Those kind of things, and then plotting with Matplotlib. Okay. So this first section right here is actually like a pretty basic section, and it's like just an introduction to Python. Okay. And so we're going to be first covering the different data types in Python. Okay. So Python is one of the most powerful tools for machine learning, and it has a lot of different data types or data values that you're going to be dealing with in your career with Python. So first it has integers, right? Integers, which are abbreviated as int, right? And these are just whole numbers like 1, 2, 3, 4, 5, 0, -1, right? 1 trillion, those kind of things. Those are integers, okay? And strings, there are strings as well. So strings are like just words or characters put together in a string of characters, right? And then lists. Lists are a list, right, of different data types. Okay, you can have a list of like a list, like you can have a list of lists themselves, and you can have a list of like integers, like 1, 2, 3, 4, 5, right? And then you can have a list of like strings, right? And it's pretty much unlimited. And then you have Booleans. Booleans are as simple as like true or false, right? So they're true or false statements. Okay. And then you have floats. Floats are like 3.14159, right? Those kind of things. Those will be in the form of a float. Okay, they won't be integers. They will be floats. They have decimal or fractional parts, right? Then there's a tuple. Tuple is just like a list, but it doesn't have it cannot be changed like a list can. So we're going to be focusing majorly on these first four right here. And yeah, and then these two right here are sort of similar to the previous one. Okay. So we're going to be starting with defining variables. So if we have like so this is how we define a variable. So there's a variable name, right? Whatever we want to call it, like age, name, height, I don't know, like number, x, y, z, or I don't know, a, alpha, omega, I don't know, right? So whatever your variable name is, you would write that over here, and then you would write equal to, and then there's something over here, like maybe it's a list, maybe it's a string, integer, whatever, right? But we're going to be focusing on variables names for now. So these kind of variable names, to variable plus, right? Those won't work because 2 is in the front, right? And then Python will register it as like a number. Then it'll see like a word over there after the number, and it won't like register properly. And variable plus that has a plus sign right there, an operator, and that is not good either. Okay, but we can also not have like spaces in between our name. So variable space name, we can't do that. And we cannot name it as a function, like a well-known function of other, or for example, print is a function in Python that's a very famous function. So you cannot name a function as a variable, okay? And this would not work, okay? And yeah, so I feel like that was pretty basic. So we're gonna define this an integer. So we can define my integer, right, without any spaces in between, to be 15, for example, right? Then if we ask the program to print out the value of my integer, right, then, or we'll learn how to do this, but then we will see that it'll give us 15, okay? And so we use the name myInteger for our integer, right? So in general, you can name your variables like ice cream, pizza, I don't know, hot chocolate, whatever, right? But it's usually helpful to name it based on what it represents, right? So our integer, my integer represents an integer. So if we ever forget what my integer represents, we can just look at the name and say, oh wait, it represents my integer, right? So usually that's sometimes helpful. Okay. Now we're going to be looking at strings. So this is how you define a string. So my string is equal to, and this variable name doesn't matter. Like I said, you can name it ice cream, whatever you want, right? And this guy right here is where we define our actual string. So equals to, in double quotes, hello world. That's going to be our string. We could have written J Sharma. We could have written like anything we wanted, right? But it has to be concealed in these double quotes over here. Or you could use single quotes like this over here, right? Single quotes would be just the same as double quotes. There's no difference whatsoever. So they're both strings, okay? And now you can define a list as, remember I said a list is basically just other data types just mashed together into a list, right? So we can have a list of -1, 0.5, 0, 1, 2, 3, right? And then hello world, like which is a string, can also be in our list. Then we can have 2, 3, 4, 5, 5, 4, and then we can have another list within a list, right? Within a list, we can have another list, which is 1, 2, 3, right? So the first element of this list would be -1, then the second element would be 0.5, then the third 0, right? And if we try to access the last element, which we'll learn how to do, we'll get this whole entire list 1, 2, 3, okay? Yeah. So then now we have Booleans, okay? So Booleans are essentially just true or false statements, right? Like a kind of binary sort of situation, right? So this is true. We're going to just label this as true, okay? And this is false. We're going to label this as false, okay? And true means like that something is true, and false means that something is false. And you can define a variable to be one of those, but that I don't really see that being too helpful anywhere. But we'll see how Booleans can be very, very helpful in if statements and while loops. Okay, so you have to capitalize this T over here and this F over here, otherwise it won't register as a Boolean. Okay, it will register as I don't know, another variable name, right? Yeah, and you don't write it in, once again, you don't write it in quotations because that would make it a string. Okay. Okay, so we can find the type, right? So basically, if this is our list from before, right, we can define a variable type to be the type of my list. So what this is saying is basically it's saying what type or what data type is this variable over here? Well, this right here is actually a list, right? This whole big thing is a list, right? So the type of the data type of that big list right here is just list. It'll print out list, okay? And so yeah, so basically, yeah, it has type list, right? And yeah, so basically we have to so what I'm trying to say is that over here we have to access it as my list with capital M and capital L. So if we don't capitalize the M and L as we did in defining the variable, it won't be the same variable as before, okay? So basically, if I define a variable A to be something, I can't refer to that variable as lowercase a, okay? Capital A and lowercase a, those are two different variables, okay? And when you're accessing that variable, you have to capitalize or lowercase it as needed. Okay, otherwise it won't be defined. So capitalization matters. So in terms of printing stuff just means like literally writing it. In terms of when you run your program, the output that you get when you print something, it'll just write it. Okay. So how you would denote this is like print open parentheses something, right? You want to print something and then close parentheses. Now we're going to see the different types of things that you can print. So you can print integers, right? So for example, if x is equal to 10, then we can print x equal or print x, and then we can print 10. Both of these guys right here will produce the value 10. It'll write down the value 10 in our output. Okay. Hello world. If we define it as hello world, then if we print these two, they will both print the, in quotations, hello world, right? And so if my name is J Sharma, then we can actually write a full sentence, and we can actually concatenate. We can concatenate strings. So by that I mean that we can put two strings together. So we can fuse two strings together. So if I wanted to, if I was given the variable like name in terms of, or if I was given J Sharma, my name, in terms of a variable, then I can print hello my name is, and then plus whatever name I was given, right? And what this does is it fuses these two strings together. So if you see my name is J Sharma, right? So if I bring that down here, it'll be like J Sharma, right? And then plus hello my name is, and it'll basically fuse those two things into one string. Okay, and so this addition operator is pretty interesting because when you add two integers, if you add two integers, you just get the sum of those two integers. Okay, like 5 plus 6, 11, right? When you add two strings, then you fuse those two strings together into one string. So hello world, if you fuse the word the string hello and the string world, you'll get hello world. Okay, all in one string. Okay, it's kind of like fusing the vectors together into a matrix, right? And then we can add two lists, so lists, right, are lists of different elements. So we can add two lists by just combining the elements that are there into one list. Okay, it's also kind of like putting together two vectors. You just take out the parentheses, then you put the vectors next to each other, and then you put parentheses around the whole thing, right? And so similarly, for lists, you would take out the brackets that you use to define them, right? You would take out those brackets, and then you would put them together, and then close the brackets on the outside. So that's how you would concatenate or add two lists. You just add those, add the elements. Okay, so if we wanted to print my age, right, and I was given that my age is 14, then we would print I am, oh, 1 second, I need to let someone in. Okay, let me see. So if we wanted to print the age, like my age is an integer, right? So my age is 14, right? which is an integer. So when we're trying to print like this whole thing, when we're trying to say that I am 14 years old, right? We're saying we want to like concatenate different strings together, right? We want to concatenate the string I am, and then 14, and then years old. So those three strings, we want to concatenate them. But 14 is not a string. 14 is an integer. But if we write string and then we put open parentheses and we put age in there, it turns out that you can actually make 14 into a string. So 14 becomes 14 in terms of a string. So you just put quotations around this guy right here. And then it becomes I am plus 14 plus years old. So I am 14 years old, okay? And so essentially what you can do is you can force that thing. So basically last time we saw how if you took 12, like an integer, and you put that, if you put str, which stands for string, and you put open parentheses and you put 12 inside, you could turn it into a string 12. And you can essentially force something to become that another thing, another data type, right? You can also force 12 to become an integer, right? So if you put, for example, if you put integer of the string 12, right? Then you would get the integer 12. So it would try to turn that string into an integer, right? But if 12 was not an integer, if 12 was like hello world, you wouldn't be able to like turn it into an integer, right? So it doesn't really make sense to do that. So if it makes sense to turn something into something else, then you can do that, right? If it makes sense to turn the string 12 into an integer 12, then you can do that. If it makes sense to turn the integer 12 into a string, then you can do that as well, right? But you can't turn the string hello world into a number. Hello world is not a number, right? Python will give you an error. Okay, hopefully that makes sense. And now we're going to be going on to like operations with integers. But before that, any questions? Does anybody have any questions? Okay. So if we're given two integers, right, we can add them by just, just in Python, you would just do a plus b if your two integers are a and b. And for subtraction, you just do a minus b. Multiplication, some of you may be familiar with this. You can use the asterisk, which is shift 8. You can use the asterisk to just do a asterisk b, which means a multiplied by b. And then division is just a, and then this bar right here, which represents division, this slash, and then b. So a slash b, okay? And exponentiation, so this would be like a times b. So it's like, it's kind of like multiplication on steroids, basically, right? So if you have two multiplication signs, that basically means a to the power of b, okay? Modulus, you can take modulus. So like finding whether a number is even or not, you can take the modulus of 2, right? If you don't know what this means, then it's okay. But if you do know what this means, you can do a percent b, and that'll be a mod b, okay? Floor division. Floor division is like a divided by b. So once again, so when you do 2 divided by signs, essentially what you're doing is first you're dividing a by b, then you're taking the greatest integer less than that, okay? So for example, 5 divided by 3 would give you like 1.6, right? And then like if you did 5 divided by 3, then you would get just 1, because that's the like greatest integer function, okay? So if you didn't understand that, don't worry about it. But these 5 up here are the ones that you want to know for sure. Okay, so so like when you add two numbers, if you add to the numbers x and y, you and store it in the variable z. So z equals x plus y. That would just be 5 plus 12, right? 5 plus 12 is 17. So you would get 17 when you printed both of these values right here. Okay? You can do any operation just the same way. I'm not going to go too deep into that because of the time constraint. Now we're going to be looking at slicing through strings and lists. Okay? Slicing through strings and lists. So we can slice through strings and lists by calling a certain element of a character, or of a character of a string, or an element of a list, right? So from this point onwards, I'm going to sort of refer to strings and lists as sort of the same thing, because a string is kind of like a list of characters, okay, if you think about it. And it's very, very similar to lists. Okay, so strings and lists are essentially the same, and we'll be looking at how to slice through a list. Okay, so we're going to be looking at lists because lists are more general than strings. So this is how you define a list, right? But with the brackets, so 1, 2, 3, 4, 5, all in brackets. And then if you wanted to print the third element of a sequence, you would print, or a third element of a list, you would print x bracket 2. Okay, and this would mean the third element. And this is because Python indexing starts at 0. So essentially what this means is that the first element corresponds to the index 0. The second element corresponds to the index 1. And the third element corresponds to the index 2. Fourth element corresponds to the element 3. So just one less, okay? So x2 would be indexing the second index, right? So this is the 0th index, first index, second index, right? So this is 2, right? So this would be corresponding to the element 3, or the third element in the list, okay? And okay, so now we're going to be slicing through a list, okay? So basically what you would do in terms of slicing a list, you would put brackets, right? So remember, when we try to access one element, we would take brackets, and then we would put one integer in here, right? So corresponding to a certain element that we want to take out. So but for slicing, we can actually take multiple elements at once. So we can take elements 2 through 4 from this list right here. Okay, and what that means is we started the element 2, we take element 2, we take element 3, but we don't take element 4. Okay, so we stop right before this last argument right here. So we have to start at the second number, or this in terms of the index, it would be the second index. So this is the 0th index, first index, second index. So we start over here at 3, and then we go all the way to the 4th index, but we don't include the 4th index. Okay, so we print 3, and then we print 4, right? But which is in the 3rd index. 5 is in the 4th index, so we don't print that, and that's it. So 3 and 4, we print 3 and 4. We print elements, or the elements at index 2 and 3, right? So the elements at index 0, 1, 2, right? 2 and 3. So 3 and 4. We print elements 3 and 4. Okay? But we don't print 5. Okay? So this is our output. Does anybody have any questions about that? Yeah, so okay, so wouldn't the integer be converted to string without the string function? Sorry, I didn't understand what you meant by that. So an integer is different from a string. Like fundamentally, it's different from a string. So integers and strings are not the same. Okay. And yes, you can take the square root of a number by raising it to the 1/2 power. So, like if you add it, then you would get an error. If you add it in and you try to print those different strings together, you would actually get an error. You actually do have to convert it. Okay, and you can raise it to the 0.5 power in order to take the square root, right? You can raise it to any power you want. Okay, let's. Okay, so we can actually and over here we talked about like getting specific elements from the list, right? We can also take from the beginning or to the end of the list, okay? So we can take up till the second element of the list, but not including the second element of the list. And then we can take from the second element of the list till the end. So this is what each command does. So when you have the colon, that means you start from the beginning. So if you have the colon in the beginning, that sort of means that you start from the beginning. Everything that's on the left of 2, right? So you start from the beginning and you work your way all the way up to element at index 2. So this has index 0, 1, and then 2, okay? And you don't print index 2, right? You print everything before that. So 1 and 2. You print 1 and 2, but you don't print the element at index 2, which is 3. So you don't print 3, you print only 1 and 2, okay? And then for this command right here, you would start at 2, and you would work your way all the way till the end. So you would start at element 2, which is right here, element at index 2, and then you would work your way till the end. So it would print 3, 4, 5, okay? Now, if you can sometimes we want sorry, sometimes we want to take the index of from the last element. So sometimes we want to take the last element of a list, right? And therefore we would take we would write -1. And what that would do, -1 is actually the last element of any list. Okay, this is index number -1. This is -2, -3, -4, right? And this one is like, I mean, I guess you would say -5, but this one is 0. So 0, 1, 2, 3, 4, but this is also -1, right? So you can iterate through the negative cycle, or you can iterate through the positive cycle. So it doesn't really matter which one you choose, okay? And of course, this one would print the last element, which is 5. And then now we can similarly print from the -4th element to the -2nd element, right? So this is the -1st element, -1, -2, -3, -4. So you can start at -4 and work your way up to -2, but don't print -2. Just print 2 and 3. Don't print the element at -2, right? So you print 2 and 3 in a list. That's your output right here. Okay, so you can find the length of a list very easily. Sometimes you wish to do that. So you can find the length of this list by just writing len. Okay, len of that list. Okay, the length of that list. And this has 5 elements. 1, 2, 3, 4, 5. 5 elements. And so that you would return 5. We can also append an element at the end of the list. So we can attach an element to the end of the list. And this would append 6 to the end of the list, right? And when we append an element to the end of the list, we have 1, 2, 3, 4, 5. But we attach another element, 6, so then we would get 6. Like 1, 2, 3, 5, 6. Okay? Okay. We can also remove a specific element. So we can remove the element at index 2 by doing x.remove 2, right? We can remove that element by its name, okay? 2 is the name of this this element right here, right? So it would delete or remove rather the element which is labeled 2. Okay, and yeah, so this would remove this guy right here, and we would be left with 1, 3, 4, and 5. Okay, we can delete similarly the element at a certain index. Okay, instead of by its name, we can delete the index. Okay, so we can delete um, the first, like the element of x that is at the first index, right? And so that's what happens when we do this. Okay, um, and yeah. And this would delete the element at the first index. So this is the 0th index, the first index, so it would delete this element right here, and it would print 1, 3, 4, 5, just like last time. Okay. Now we're going to be looking at conditions. Okay, just a little bit longer, and we'll continue this tomorrow. So conditions will print whether or not something is true. Okay. So first we start with a refresher on Booleans. So Booleans are true or false statements, right? So there's a couple of statements for, at least for integers, that can be satisfied, or like you can write for in code for yeah. So first you have equality, right? So equality works for any data type. So it just means that variable a and variable b are equal to each other, and you would write that as a equals b. Okay, if you write just a equals b on a certain line, that will set the variable a to be equal to what variable b is. Okay, so a and b are it'll say that a and b are the same thing, right? And that'll return true if they indeed are the same thing, and it'll return false if they are not the same thing. Okay, not equal to means that so you would put an exclamation point, then an equal to sign, then the other variable. So you would do a exclamation point equal b. So this means that a is not equal to b. Okay, and so this works no matter what a and b are. So this basically just says that a is not equal to b, like the string hello world, capitalized all caps, is not equal to the string hello world where it's all lowercase, right? So they're not the same exact thing, and that's why Python will return true if you say a is not equal to b. Greater than. So if for integers, if a is greater than b, then it'll return positive, or it'll return true. Less than is a is less than b, so it'll return false, or it'll return true if if a is indeed less than b. Greater than or equal to, so a is greater than or equal to b, meaning that a is greater than or equal to b, of course, right? And so this is how you would denote it. And so this would be like a is greater than or equal to b, and it would return true. For this case, less than or equal to is defined similarly. And now, like we can, if x is 10 and y is 123, we can print x is greater than y, x is equal to y, and x is less than y. And this will print a Boolean saying whether or not x is greater than y. So x is not greater than y, right? Obviously. So it'll print false. And this guy right here, x is equal to y. These two are not equal to each other. So this right here is false. X is less than y is true, right? Because 10 is less than 123. So the third one is true. False, false, true. Okay. So wait, does anybody have any questions? Okay, I sorry for taking so long. It's kind of very long unit. So yeah, so let me see. Okay. Yeah, so we can also use and statements. So and is basically like if you have condition 1, as we just discussed, and then condition 2, if you print that, it'll only return true if both of these conditions are true, okay? And or statements will be true if and only if both, or like if only if at least one of these statements is true. So if both statements are true, great. If one statement is true, also great. If both statements are not true, then you have a problem, right? It's going to be false. Not will, like if you print not condition, right? That'll return true when the condition is not satisfied. Okay, it's kind of like the opposite. In is like if A is in B, that means that A is inside, like within B, you can find A. Okay, so like if you have a list, which is a subset of a larger list, you can print this smaller subset in that larger subset, and then you'll get true because one is contained within the other. Okay, now we're gonna see if statements where you can apply these things that we learned. Okay, so we can basically say if some condition, right? Some condition, we insert some condition there, and then colon, and then there's an indent over here, and then there's some action that we execute. So this is basically saying that if my condition is true, right, then you have to execute some action. And notice this indent over here. There has to be an indent over here. And otherwise it won't parse correctly. Okay. And yeah. So for example, we could do if 3 is greater than 2, print 3 is greater than 2, right? And so 3 is greater than true. So 2. So that is correct. So we would go down here and we would say print. We would say 3 is greater than 2. Okay. So that's how you would do it. We can also do else statements where if a statement is true, you would do some action, but else, if the statement is not true, right? If this statement over here is not satisfied, then you'll execute some other action. So if 3 is greater than 2, print 3 is greater than 2. But if it's not greater than 2, which we know it is, else, right? Or else print this, 3 is not greater than 2. Okay. Now you can also do Alif statements where like if some condition is true, then you do something. Whereas if that condition is not true, if condition 1 is not true, then okay, go down over here and check to see if condition 2 is true. Okay, so else if, like, so if this is not true, then else if condition 2 is true, then you can execute this action. But if both of these conditions are not true, then it won't run any of these. Okay, so if 3 is greater than 2, print 3 is greater than 2. Else if 3 is equal to 2, then you can print 3 is equal to 2, right? Yeah, so it'll check to see if this statement is true. If this statement is true, it'll run it, and then it'll just skip to the end. But if this statement is not true, it'll go to here and check to see if this is true. If this is true, then it'll run this and then go to the end. Otherwise, it'll just go to the end, right? Without executing. So in general, you can write if some condition, then action, right? If some condition is true, I want you to perform some action. If some other condition is true, I want you to perform some other action. If some other condition is true, and so on, right? So you can write if some condition is true, then else if another condition is true, then else if another condition is true, right? So more Alif conditions, then else. So if nothing over here, no Alif statement over here is true, and none of these conditions are satisfied, then you can do some action. If like, so basically this action will only happen if no other condition is satisfied. So because there's an else statement right here, this if statement will always run no matter what. If these conditions are true, then it'll run those statements. If these conditions are not true, then it'll run this else statement. Okay. Yeah. So you could do a is equal to 10, b is equal to 20. So if a is greater than b, then print a is greater than b. Elif, right? In another case, a is equal to b, right? If a is equal to b, then you would print a equals b. Else, you can print a is less than b. Okay, a is less than b. So if it's not greater than b, if it's not equal to b, then it must be less than b, right? So a is less than b. Okay, and you can also use and or statements similarly. So you can say if a is greater than b or a equals b, then print that a is greater than b or a is equal to b. So you can use and or statements. Okay. And in your conditions, and then you have for loops. Okay. For loops are if you want to perform some action a certain number of times. Okay. So if you have if you have this kind of for loop, right, the first type of for loop, then you say that for some variable, you basically say a variable name up here, right? So some variable in range of number, right? Some number, then execute some action. Okay, so basically it's gonna this some variable right here, which is sometimes named I or J. So for I in range number, right? So I will iterate through every single one of those numbers. So for I in range 10, that would iterate through 0 through 9. Okay, so because indexing in Python starts at 0, so it would go to from 0, 1, 2, 3, 4 all the way to that number minus 1. So this would print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. Okay. And so you can print the elements of a list. So you can actually go iterate instead of iterating through numbers. You can iterate through the length of a list. Okay, so you can iterate through the length of a list, and for each of the values of I, right? I goes through the values, because 1, 2, 3, 4, 5, right? So x has length 5, right? So len of x is 5. So I will iterate through 0, 1, 2, 3, 4, all the way up to 5, right? So it'll iterate through 0, 1, 2, 3, 4. And for each of those values, x of 0 will be 1, x of 1 will be 2, x of 2 will be 3, x of 3 will be 4, x of 4 will be 5. So it'll basically just iterate through each one of these elements in the list, right? Not directly, but once you say x of I, then it'll iterate through every element of x. Okay, and so you can actually directly iterate through every element of a list or string, right? And basically you say for I in x, right? For I in x, print I. So for I in x means that you print, or basically I takes on the value of each of these elements over here. In x, that would mean in this list of x, print I. So for every single value of x, for every single element in x, you would print that element, okay? And you would just get 1, 2, 3, 4, 5, all on different lines. And so if we have this same list again, we can do for I in x, and we can actually do a break statement. So print I, right? But if I is equal to 3, then we break. What this says is basically it's taking on the values 1, 2, 3, 4, 5, right? That's what it's supposed to do normally. But so basically we go over here, we print 1, we print 2, we print 3, but then as soon as it equals 3, we break. Okay? And what it means by breaking is that you'll break out of this for loop. You'll break out of this for loop and go to the end right here, okay? And you'll just ignore everything else at the end. You won't go through the rest of the iterations at all, okay? And yeah, so you can also do continue. So for I in x, if I is equal to 4, then continue. Otherwise, print I. So basically, continue means that it will just skip over everything at the bottom, and it'll go to the next iteration of I. So if so, basically, I is going through 1, 2, 3, 4, 5, right? That's what it's normally doing, right? Then basically, once it becomes 1, then it'll just pass this if statement because it's, this right here is not true. Then it'll print I, so it'll print 1, 2, 3. And then when it comes to 4, it'll be I is equal to 4, right? So I is equal to 4, that statement is true. So it will continue. It'll go on to the next iteration without printing this right here, okay? So it'll print every single element except for 4. Once it becomes 4, it'll just skip everything underneath. That's what continue does. While loops are very, very similar to for loops. And essentially what you would do is you would basically you have some condition, right? So while that condition is true, then you just do everything that's in the bottom. So for example, if so I is equal to 0, right? So while I is less than 10, you would print I, and then make I into I plus 1. And so this is kind of the thing that you would see in Java, I think. And so basically, it takes on the value of 1. It takes on the value of 0. Then 0 is less than 10. That's true, right? So it would print 0. Then it would increment I by 1. So I would be increased by 1. So 0 would become 1. So 1 is less than 10. That's true. Then it would print 1. Then it would print 2. Then it would print 3. All the way to 9. Then once it's 9, then it would increment by 1. And then it would become 10. And so 10 is less than 10. Well, that condition is not satisfied. That's false. So it'll skip everything over here, and then it'll just exit the while loop. Okay? Okay, so, sorry, there are a few questions here. If you do 2 in 4, will it return false? Yes. If can you change the value of the range or variable I to break out of the for loop when you are within the loop? Can you change the value of the range or the variable I to break out of the loop? Wait, so you want to change the value of the range? Wait, so you can change the value of the range once you've started it, but basically when you break, it just skips over everything else, and it basically caps off at a certain number of iterations. So that essentially that range that you gave becomes a void if that break statement is run. So can you explain more, like what do you mean? You can, like, within your for loop, if you say for I in range 10, you can say I is equal to 1, and then it'll just keep on like running forever and ever and ever, because it will never reach to that. It will never reach to 10. You got it now? Okay. So let me know if you have any questions. Yeah. So I equals 0 while I is less than 10. Print I, and then I plus 1. So that this would just go through 0 to 9, and once it becomes 10, it would not satisfy, so it would break out of this and then go down there. Okay. Now we go on to Numpy arrays. So I feel like a lot of that might have been review for you. Okay. So now we go on to Numpy arrays, and I just want to go through a few examples because we're running pretty like a lot over time, right? So we'll just do a few examples, and then we'll end the class. Okay, and then we'll continue this tomorrow. Okay, but I wanted to do this because of your homework. Your homework is working with Google Colab, and in order to do that, you need to know about Numpy arrays. So I'm just going to do a few examples of that. So in order to work with NumPy, you have to import NumPy first. It's a library, so you have to import the library, and you would write import NumPy. And for convenience, like instead of referring to NumPy as NumPy, right, every single time, you would just write NP. So you would import NumPy as NP. That's what people usually call it. You could just import NumPy as N. You could import NumPy as like ice cream, right? But usually we say NP, right? Again, because of that variable naming, right? So now you define a variable or an array, a NumPy array, by saying, like, giving it a name and saying that it equals np.array, right? That'll run the command, like it'll say like, okay, you're about to type in an array, right? So then you have to do open parentheses and then write your array in here. And your array is kind of like a list of numbers. So if you had a list of numbers, you could just type that into there, and your array would just be a row vector, which is 1, 2, 3, 4, 5. Okay, and we could transpose this array or transpose this vector, row vector, and essentially this row will become the column. So it'll become the column vector 1, 2, 3, 4, 5. And we'll figure out later how to do that. That's actually your homework for tonight. But yeah. So we can actually manually define like a column vector. And so the way we would do that is having two sets of parentheses. So the first set of parentheses, all that means is like if you have two sets of parentheses, you're dealing with a matrix in 2 dimensions. So now you have a matrix in 2 dimensions, and you're writing 1, 2, 3, 4, 5, each within their own set of brackets. So you have two sets of brackets here. One set of brackets around the whole entire thing, and one set of brackets around just the number, right? So what this would do is it would print 1, 2, 3, 4, 5, all in different columns. Okay. And so by this logic, if you just added more numbers within this, right? So you could just add more numbers. You could do like 1, 2, 3, 4, 5 instead of that, instead of just 1. And you could do like 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on until 25. And you would end up with this vector right here, sorry, this matrix right here, where 1, 2, 3, 4, 5 is your first row over here, 6, 7, 8, 9, 10, second row over here, and so on and so forth. Okay? So it's kind of like a list that contains lists, right? And if you don't have the same number, of elements in each row, Python will not give you an error. It'll just give you, it'll just consider it to be a list instead of a NumPy array. Okay? Now we're going to be moving on to operations, and I think just around here I'm going to cut it off. So operations with NumPy arrays. So for operations with NumPy arrays, we would do like maybe matrix addition, right? So if we wanted to do matrix addition, right, we would write some array over here that we defined earlier, right? How to make arrays. So this would be my array 1 would be some array. My array 2 would be some other array, and in order to add these two arrays, we would just add them, right? Like my array 1 plus my array 2, okay? And so this is a demo of that. So I ran this, and so import numpy as np. My array 1 equals some array. My array 2 equals some other array. This, and then I'm going to print the sum, which is my array 1 plus my array 2, okay? And if you notice, it prints the sum of the corresponding components of each of these arrays. And so 1 plus 6 is equal to 7, and this right here is 7. 2 plus 7 is equal to 9, that's equal to 9, and so on and so forth, right? For example, scalar multiplication is is when you multiplied some array by a number. Okay, so for example, if you defined this array as 1, 2, 3, 4, 5, you could multiply it by 3, and you would be multiplying each element by 3. So this one would become 3, 6, 9, and then 12 and 15. So 3, 6, 9, 12, and 15. Okay. You can also, so let me see. Yeah, you can also do any operation you wanted that, like any operation, for example, like element-wise multiplication. So what that means is if you have two arrays with the same dimensions, you can multiply their corresponding elements, and this is called element-wise multiplication. And in order to do that, what you would do is, um, in order to do that, what you would do is you would put an asterisk in between these two arrays. You could divide these two arrays, and that would divide the corresponding components. You could like take the modulus or whatever, right? You could just do basically any operation upon the corresponding elements if they have the same dimensions. In order to do matrix multiplication, you would do myArray1 dot. So you would do a dot, and then you would write literally dot, and then you would do open parentheses myArray2. So what this would do is it would do matrix multiplication of array1 and array2. And if they're not defined, if the matrix multiplication is not defined, it'll return an error, which will sometimes happen in machine learning algorithms. Okay. Yeah, so now we're going to be seeing how we can take the size and shape of an array. Okay, so if you you can take the size and shape of an array by doing, or you can actually first actually let me go through this right here. So you can print the shape of an array by printing myArray.shape, and that would print the dimensions. So sorry that. Yeah, so if you see down there, it says 5, 5, 4, and right around here. But yeah, so 5, 4 are the dimensions of this array right here. This array has dimensions 5, 4, which means it has 5 rows and 4 columns. And because it has 20 elements total, 5 times 4 is equal to 20 elements in total, I can reshape this vector, or sorry, reshape this matrix as a 2 by 10 matrix. Okay, a 2 by 10 matrix, which will be like basically it'll just like put reshape these arrays, this array into a 2 by 10 matrix. Okay, nothing too complicated. And then you can take the size and the shape. The size will be like the number of elements, and the shape will be the dimensions, as I said before. Okay, and this will be presented in a tuple. The shape will be presented in a tuple. Okay. Yeah. So I think we can break it off right now, and I'll just go on to the homework. See. Now we'll go on to the homework. So we covered the basics of Python today, as well as like Numpy Arrays. We didn't cover all of it. We're going to be covering the rest of it tomorrow, as well as Matplotlib. But the homework is very, very important, and that's why I kept you guys extra long over here. So this right here is Google Colab, and I wanted you to try Google Colab. And basically, first save the Google Colab to your personal Google Drive. So Google Colab, as I said before, is a very powerful collaboration tool for machine learning. And so you cannot, like, any changes that you make will be saved to your drive. So what you can do is you can save a copy of a certain file that you find into your drive. Okay. So I want you to run the cells. The cells meaning like there are different cells in the Google Colab. And I want you to run each of these different cells. And I want you to complete the code to transpose a given matrix. Okay, slide 72 will give you the information that you need to do that. Even though we didn't go to slide 72 yet, you can look at slide 72 and adjust it and save it to your drive. Okay, that'll be a really helpful exercise in doing Google Colab. Okay, and that is it for the class. I'm so sorry I kept you guys late. And so what I would recommend is going over the slides, reviewing the handout that I will give you, and make sure you understand these two at least, basic Python and NumPy. Okay, that's it for the class. I'm so sorry I kept you guys late, but yeah. So does anybody have any questions on that? Okay. Yeah, make sure to answer the review questions on Google Classroom, okay? I'll be posting those, as well as a handout on this. So you can go more into depth and read the explanations if you get confused. Thanks. I'm so sorry I kept you guys late. Hopefully you guys are learning a lot in the process. Thank you. See you tomorrow. Does anybody have any questions? Okay, I'm going to end the recording now.